What's going on, guys? Happy Friday. You have made it through your first full week of virtual learning. I'm really looking forward to getting you guys in here next week so you can show me, you can prove to me that even though you've been home, even though you've been kind of learning through videos, when you get here on Monday, you're going to be ready to hit the ground running, and we're going to pick up right where we left off. So today for math is really just going to be pretty short and sweet. I want to do a little review of all the types of data and graphs that we've looked at, because when you come in on Monday, we're going to use all that information that you guys have learned. We're going to have a Graphing Jeopardy, which would be a nice little review, and that'll lead right into your graphing quiz, which we will take. So you've had all the videos, you've had all the lessons, you've had everything that the students in class have had, so you'll be ready to take that quiz on Monday when you come, but we'll have a little fun with that Jeopardy first. So this says interpreting graphs. Really, you could say that. It could say interpreting data. But when we started, the first one that we looked at was a frequency table, which you have here. And what we started with determining the difference, or being able to identify the difference between numerical data and categorical data. So here, if you look at this frequency table, it's measuring the number of pets. And if somebody's going to ask you how many pets you have, obviously you would say 0, 1, 2, 3, however many you have, which would be numerical data. So if you look here, got all your pets. You had 4 people with 0 pets, so we would put a 4 right here. We had 6 people with 1 pet, you'd have a 6 here, 5 people with 2, 3 people with 3, and then you had 2 people who had 4 pets. I'm not as worried about you making the graphs as I am you being able to pull the information from it in order to help you answer some questions. So number 1 says how many pets had the most people. Again, you would list your frequency right here. But again, you can give this the eye test. You can look at the tallies, and the answer for number 1, you could say that 1 pet was the most frequent answer. So for this, we would have had. All right, and looking at number 2, it says how many people owned 2 or more pets. So that goes back to that example we talked about yesterday's video with the line plots. If it says you have to be this tall or higher to ride, if you're this tall, you're good. Everything beyond that is good. So if you own 2 pets, you're good, and anything more than that would count too. So we're looking at people with 2 pets, 3 pets, and 4 pets. So how many people own 2 pets or more? See if you can get that answer while I count it up. If you added that cluster of 5 plus 3, you're going to get 8. Plus 2 more, you would have had a total of 10 people. Again, kind of when I ask these questions, I want you to try and pause your video because I'd rather you get the answers instead of hearing me talk about them. And then after I read number 3, pause your video, see if you can get this answer. It says, what is the combined, important word, what is the combined number of people that own 0 or 1 pet? So you had 4 people who owned 0 pets. You had 6 people who owned 1 pet. Combined means I got to add 6 plus 4. That would have also been an answer of 10 people. So that is just a quick example of a frequency table. And in our lesson, we took a frequency table, we just turned it into a bar graph, which you see here. Obviously, this is not using the same data. This is something completely different. Before we even look at these questions, I don't know if you can see this. I'm hoping you can. We talked about there's 4 things that a bar graph has to have. It's got to have labels. It's got to have a title. It's got to have a scale. And then obviously, you're not going to have a bar graph without bars. So if we look at our bar graph, we know that this is the gemstones, the number of gemstones we have in Mrs. Cooper's class. Down at the bottom, our labels show the types of gemstones. And then over here, we've got our scale. Obviously, we're counting by 2. So anything that doesn't land on the line, if it lands in the middle, we're going to be able to figure out that number based off the scale. And then you've got all your bars, and they're represented by different numbers. So same deal. I'll read the question. I'll go into how I would solve it. But once I read it, I want you to pause it, see if you can get the answer. It says, which gemstone appears most often in the collection? So most often, if we're talking frequency table, would be you see this the most frequently. Give it the eye test. Look at the bars. See which one goes the highest. And clearly, the emerald would be the one that is Sorry, I hope you cannot see that blocking the question. The emerald is the one that appears the most often. If you want to know the number, you could follow it up to the top, trace it over, and the number that comes between 10 and 12 would be 11. So for number 2, it says how many kinds of gemstones had less than 5 stones in the collection? Less than 5. If it has 5, that's not less than 5, that is 5. The way I probably would have done this one is I would have found where 5 is and kind of put my cursor right there, and I would have just traced over. Probably would have been be easier with my finger, so I'll try to keep it straight and see which ones, or see how many bars are less than that. Like a garnet, I wouldn't count because that is 5. I'm looking for less than 5. All right, so opal, definitely, there's one. Pyrite, definitely, there's another one. Keep going. Topaz, less than 5. Sapphire, less than 5. Calcite, less than 5. Ruby, less than 5. That would give me a total of 6 gemstones that we had less than 5 stones in that collection. All right, number 3. Oh, man, these keywords, I'm fingers crossed we know what to do when we see these now. It says how many more students have quartz than topaz. That means I only need to look here and here. How many more means I have to subtract. With quartz, I had 7 gemstones in that collection. Topaz, I had 2. If I did 7 minus 2, that would give me my answer of 5. And last but not least, see if you can get the answer for this one. It says, what is the combined total, 2 keywords, for turquoise, opal, and sapphire? So you've got 3 different gemstones. You've got your 2 keywords that tell you to add. So let's look at turquoise first. Turquoise has 6. And let's go ahead and add one at a time. Opal has 2. 6 plus 2 gives us 8. And then if we add sapphire, which has right here in between 2 and 4, it has 3. 8 plus 3 would give us 11. So again, not as worried about you creating one as I am being able to pull out that information. So if we're following the track of how we did this, frequency table, then bar graph, then we looked at double bar graphs. I've said it in class, I said it in the video. When you see a double bar graph, the first place you need to look is the key. And honestly, you need to refer to the key for every single question. And just like a normal bar graph, it's got the 4 things it needs. It's got a title, student's music choice. It's got the labels. They could have chose rock, classic, or country. And it's got the scale, which again, we're going by 2s over here. This would be categorical data, because if you ask somebody what their favorite type of music is, they had their choices, rock, classic, or country. All right, and then if I look here at the key, the boys were the blue bar, the purple bar were representing the girls. So we'll look at that for every question. So see if you can figure out number 1. Which music has the least number of boys that voted? So again, boys, that's going to be our blue bar. And if I'm looking here, rock, classic, country, country clearly had the least number of boys. So we're just doing the eye test on that one. Really didn't have to do much math. All right, have to do a little bit of math here. Oops, sorry about that. Number 2 says, what is the total number of students that like rock music? So we're not saying boys, we're saying girls, we're saying students. So we got to take both of these bars and figure out our total by adding. So if we follow the boys bar for rock, they've got 9. Look at the girls, they're in between 10 and 12, which gives us 11. And if we did 11 plus 9, that would give us a total of 20 students that like rock music. All right, number 3, another keyword that we've seen a bunch. It says, what is the difference between the boys who liked rock and the girls who liked country? So I like this question because you're looking at both genders, but then you're also looking at 2 different types of music. You're going to have to look at a couple different spots. So first, let's look at the boys who liked rock. Blue bar, 9 boys. All right, then let's look at the girls who liked country. That means we got to look purple bar right here, and that was 3. Difference means we have to subtract. If we went 9 minus 3, that difference would be 6. Last question I want to ask you for the double bar graph. Again, see if you can figure out this answer before I start explaining. Pause button. It says, how many girls voted for classic and rock music? So I'm going to refer to my key. Girls were purple. Here's classic. Here's rock. Rock had 11 girls, which we figured out a couple questions ago. Classic has 5 girls. And if I go 11 plus 5, that would give me a total of 16 girls who voted for classic and rock. Even though that one kind of puts the most in front of you, I think if you look in the key, those questions aren't that challenging. I guess it really depends on the scale, how big the numbers are. When you're dealing with numbers that small, it definitely doesn't pose as much of a challenge as some that you may see down the road. So last but not least, we looked at line plots yesterday, which you also saw in your Fantastic Five. And I've got this on 2 different slides, but it's the same line plot. If you look at the top, it's showing the amount of recycled paper per class in kilograms. So you've got 5 kilograms, 6 kilograms, 7, 8, all the way up to through 13, tongue-tied. And this would be showing numerical data because we're dealing with numbers. It says how many classes participated in the campaign. So remember, these X's are going to be the classes. The numbers at the bottom are the kilograms that they recycled. So all you got to do is count your X's for number 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 classes participated in the campaign. Number 2, this is just like a question we had with the frequency table. It says how many classes recycled more than 9 kilograms of paper. So here's where 9 kilograms is. More than that means 10, 11, 12, and 13. 9 kilograms is not more than 9, it is 9. So I'm looking right here at 10, 11, 12, and 13. Anything beyond. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 classes recycled more than 9 kilograms of paper. 2 more questions I want to go through. Again, I told you we're just going to be short and sweet, even though it's kind of a lot of different stuff to look at. Number 3 says how many classes recycled less than 8 kilograms of paper? Again, here is where 8 kilograms is. If I'm talking less, I got to look at 7, 6, and 5. 8 is not less. 8 is 8. So if I'm looking at 7, no classes there. 6 had 1, 2, 3, plus 1 more with 5. That should have been 4 classes that had less than 8 kilograms. And last but not least, it says, what is the total amount of paper that was recycled? Pause this video and see if you can figure this out. Now, before you do that, these numbers represent the kilograms. The X's represent the classes. Guys, this right here means one class did 5 pounds. This class did 6 pounds. This class did 6 pounds. This class did 6 pounds. Think about that question and see if you can solve it. Okay, so I'm going to get my annotation button here. Let's see. All right, guys. If I want to know the total amount of paper that was recycled, let's start with the 5 pounds. We had one class that recycled 5 pounds of paper, or 5 kilograms, I'm sorry. Boom, there's 5 kilograms. All right. Moving over to the 6, there were 3 classes that recycled 6 kilograms of paper. That means 6 here, and 6 here. That is not just 6 pounds once. That's 6 pounds 3 times. So you can do 6 plus 6 plus 6. You can do 6 times 3. Either way you do it, those 3 X's, those represent 18 kilograms of paper. So if I wanted to, I could go ahead and add those 18 kilograms plus the 5 that I already had. That's supposed to be a 1. That looks awful. So right now I've got 23 kilograms of paper. And I'll keep going. Get my thing back. Can I put it right here? Yes. All right. Nobody had 7. And then if I could look at 8, there were 2 X's for that, meaning 2 classes that had 8 kilograms of paper for a total of 16 kilograms of paper. If I add that 16 to the 23 that I already had, 6 plus 3 is 9, 2 plus 1 is 3. Right now I have 39 kilograms of paper. So if you were way off with what your answer was and how you started to solve this, why don't you stop this video again and pick up where I've gotten you to. We've already done this. We've done the 6, nothing for 7. We've done the 8. See if you can pick up now where I left off to get a different answer. Excuse me. Okay, so right now we have 39 kilograms of paper. Get my number back up here, maybe. And now I'm looking at 9 kilograms. 4 classes did 9. That means 9, 9, 9, and 9. You could do 9 plus 9 plus 9 plus 9, or you could do 9 times 4, and you would know that that is a total of 36 kilograms. In the ones place, if I did 9 plus 6, that's going to give me 15. 5 stays, 1 goes. And then 3 plus 3 gives me 6, plus 1 more gives me 7. And I can mark that off the list. Keep it going. Looking at the 10 kilograms, there were 1, 2, 3, 4, 5 classes that recycled 10 kilograms. 10 plus 10 plus 10 plus 10 plus 10, or 10 times 5 shows me there were 50 kilograms total there, which if I added those together, gets me to 125. Ooh, fella. 125 kilograms. Let's get back where we were. We're done here, done here, done here, done here, done here, done here. We're at 125. Again, we're moving to 11 kilograms. There were 2 classes there. So you can go 11 plus 11 or 11 times 2. That gets us to 22. Add those together. 5 plus 2 is 7. 2 plus 2 is 4. Bring down the 1. We are at 147 kilograms of recycled paper. A couple more options left. Now we're looking at 12 kilograms of recycled paper. 3 classes that did it. 12 plus 12 plus 12, or 12 times 3. That gives us 36. We'll add those together. Right now I'm sitting at 183 kilograms of recycled paper, with 1 last class left that recycled 13 kilograms. And if I add those together, that would give me a total of 196 kilograms. So you've never seen a question quite like that before. You will see it in your Jeopardy on Monday. You might even see it in your Fantastic Five next week. Wink, wink. So if you're watching this video, which you should be, hopefully you are going to have an advantage over somebody who may not have. So I said that was going to be short and sweet. Maybe I talked a little bit more than I thought, but I think it's a good thing just to see all that stuff one more time. There's no assignment or homework. The only thing that I do want you to do, if you have not, hopefully you have already, that iReady diagnostic has got to be finished by this afternoon. If it's not, you may have to start it over, and I don't want anybody to have to do that. So if you watched, just again, Jeopardy on Monday, quiz on Monday, and I think you'll be in really, really good shape if you have been utilizing these videos. So if you are watching, thank you very much. Appreciate you working hard. Great first week of virtual learning, and the real fun starts next week. See you then.